Whoa! Welcome guys. So please subscribe to my channel before I start. So in this video, I want to answer a question. So I want to answer a question is that suppose you are given a polynomial with degree, let's say n, and so this is your polynomial, and let's say you have let's say alpha I is a root, alpha I are roots of this polynomial, and then let's say a0 is non-zero. Okay, and I want to ask how to compute. The first one is that the sum of the inverse of these roots, right? Since a0 is non-zero, so all the alpha I are non-zero. Okay, and the second is that I want to ask what is the sum of the square. Okay, now you can do the other derivation after I tell you how to compute these two. Okay, so before I start, let's talk about a simple stupid equation, stupid example. Suppose you got the quadratic, right? So let's say you get the x squared plus alpha plus beta plus x. So this is x squared, let's say, plus ax plus b, right? So this is your case. So in that case, that if you get this, then all you get is this one, right? This guy. So this alpha plus beta is negative a, alpha times beta is b. Okay, so this is your answer. Okay, now let's talk about the cube one. So everybody knows about the cube one, right? So you just times it, and you get alpha plus beta gamma plus alpha gamma x minus alpha beta gamma, right? So if you add the three of them, you get the beta gamma, alpha gamma plus alpha beta, which is exactly this. So let's call it C, let's call it D. So it's C divided by D. And then there is a negative sign. Okay, so I guess somehow you guys already see the pattern is that the answer always be a negative sign, but with the second last coefficient divided by the final divide the final coefficient. Okay, so but is there a systematic way that can prove it? So the idea is that the answer is yes. So let's quickly go through. Let's say we have p of x, which is our polynomial. So it's x minus alpha 1, alpha 2, up to alpha n. Okay, so what's the next step, right? The next step is that suppose I take a derivative, then I will get what? I will get this one, right? So x minus alpha 2 minus alpha 3 alpha n, right, plus x minus alpha 1, and we skip alpha 2. Right, so now you get a tree. So final is that we skip the alpha n. Okay, so that's p of x divided by p of x, p prime of x divided by p of x. Then we will get this what? We will get this one, right? Nice. So now you see a trick. So that's that x equals to 0. So if x equals to 0, then we get the sum of the inverse of roots is just this. So this is our answer. Okay, so let's quickly see is this correct at this time. Okay, so in this quadratic case, that the p of x is x squared plus ax plus b. So p prime is just 2x plus a, right? So p prime of 0 divided by p of 0 will be a divided by b. And then there's a negative term here, right? So negative term. So which is exactly what we get. Okay, so this is the equations, the answer what we got. Okay, and the second example that I think everyone's know how to do this, right? So what should we do, right? So what should we do? So the idea is that what should we get this, right? So then suppose we do the differentiation with respect to x again, right? So that's d dx p prime divided by p, then we will get this one, right? So now you see the trick. The trick is that we just let x equals to 0, then we will get the answer, right? So we will get the sum of alpha I squared. Well, inverse alpha I squared will be ddx p prime of x, p of x, and then make x equals to 0, which is p squared, and let's say p double prime and p prime squared. Is it correct? Let's see. P double prime minus sorry, there's a minus sign here. Sorry about this. Yeah, so I'm stupid. Yeah, so there is a minus. Let's see. So the first term is p double prime. Sorry, I'm old. Okay, so the first term is that p double prime divided by p plus p prime, right? So this one is negative p squared p prime. Okay, yeah. So it's this one. So it's p squared p prime and p prime squared. Okay, and then you just take the x equals to 0. Then this will give you the beautiful answer. Okay, and if you differentiation third time, and you take the roots, then you can get this, right? So by definition, you can always get this. So you can compute the arbitrary inverse power n by just using this formula, this idea. Okay, so let's quickly review the first two. The first two is this, and this one. P prime 0 0 minus p prime 0 square p square 0. Okay, in the next video I will talk about how to compute this, right, when n is positive. Okay, now I hope to see you guys in next videos to prove that how do we compute this. So this can be computed by using the generating function recursion formula, but I will try to think a way that which is novel to give you the answer. Okay, now I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.